This is part 2 of section 4.4. And this is just an image to remind you that we can go around the unit circle as many times as we need to, and we're still going to be talking about the same terminal point, so we have the same trig value. We have the same x value, same y value, so we have the same sine and cosine functions. And all this is saying here is that for every real number, I can add 2 pi to that number, and I'll have the same sine value. And here I have the same cosine value. This is talking about coterminal angles, which we've already been dealing with. And basically, this just means that the sine and cosine functions are periodic with period 2 pi. They start repeating themselves every 2 pi units. Okay, so to summarize what we know so far, if we're trying to talk about y is equal to sine of t, so this is our most basic sine function. Our domain is all real numbers. We can plug any value in for t. Our range is -1 to 1. We will only get y values in that region. We have zeros when t is equal to a multiple of pi. An even multiple, or odd multiple, positive, negative, doesn't matter. N could be any integer, not a fraction, any integer. Okay? Now, here's something we haven't talked about exactly. We're going to have a maximum value of 1 because that's the largest answer we can get. Where does that happen? The first time it happens is at pi over 2. And so we know that we can add multiples of 2 pi, and it's going to happen at every point there. Okay? Our minimum value is -1 for sine, and that first happens at 3 pi over 2. And we know that that's going to repeat for every trip around the circle. So for every multiple of 2 pi, we've got it. Okay? We know that we have an odd function, which means that sine of -t is the same as pulling the negative out front and sine of t, and the period is 2 pi. Now for cosine, our domain and our range are the same as here. We've talked about how we have zeros at pi over 2, and then every multiple, we can add pi to that every time. We have a maximum value of 1 at t equal to 2n pi, where n is any integer. So we have a maximum value of our maximum value for cosine is 1 at 2 pi, also at 0 and 4 pi, so on and so forth. We have a minimum value of -1, and this first happens at pi, and then we're going to add multiple values, multiple trips around the unit circle to find -1 again and again. We know that cosine is an even function, so if I'm finding cosine of -t, that's the same as just finding cosine of positive t. And we know that this also has a period of 2 pi. Okay? Now, let's talk about what these graphs actually look like. What I have here is just a chart of our sine values between 0 and 2 pi. These are the ones that we have on our unit circle. It's just pulled it off, so we have a t-chart. So these are our x values. These are our y values. And when you're plotting these onto a graph, it looks a bit like you are unrolling the unit circle. So here I have the unit circle and our sine values, and you can sort of see it's like it starts off here and then it's unrolling and you have your sine values going along over here. Okay, so first our sine values are positive and getting bigger, and then our y values start getting smaller. And then over here our y values are negative, so they drop below. And they keep getting smaller and smaller, so this keeps going down, and then it starts heading up again. So we go back up to here. And we get all of our sine values between 0 and 2 pi. Okay, now, so this is just over one cycle, it's over one period. And so if you want to make it more general, this is your basic graph. Here's your sine x, and that's the cycle we graphed, and we know it's periodic, and so we repeat the same shape over and over again, and we know also that this should be an odd function, so it should be symmetric about the origin, and it is. So once we know what one cycle looks like, we can create a graph covering as much as we need. Now, if we do the same type of thing for cosine, and these are the cosine values I've pulled off the unit circle, and again, it's sort of like unrolling it. Okay, so here we're talking about our x values instead. At the beginning, our x value is 1, and then as we're going along in this direction, our x values get smaller and smaller, and then over here, our x values are negative, so they drop below the x-axis, and it keeps getting smaller and smaller. Okay, and then our x values start increasing, but they're negative still, and then over here, our x values are positive, so we're up above the x-axis here, but they are increasing, so they go back up. Okay, so if we're talking about doing it like this is the cycle we just graphed. We know that the period is 2 pi, and that is what we've graphed it over. That's one cycle. And so we can repeat that as many times as we need to. We know that cosine function is even, so it should be symmetric about the y-axis. And you can see here that if you fold it, it is. Okay? Now, we're going to talk about 5 key points because we are going to start moving these things around a little bit. So basically, we have 5 key points for each of these for sine and cosine. And what you want to do is you want to locate all of your x-intercepts. So here it's 0, 0, pi 0, and 2 pi 0. Here it is pi over 2, 0, and here it is 3 pi over 2, 0. And you also want to locate your highest point and your lowest point. Here we have 2 high points. Here's our low point, high and low. If we can do this, and if we can adjust those 5 points appropriately, then getting a graph out of that is not that difficult.